Hey guys, today's video is about special graphs called histograms. In this video we'll be answering the question, what is a histogram, why do scientists use histograms, and how do you make a histogram? When you first see a histogram, it looks a lot like a bar graph, but there's some differences between bar graphs and histograms. If you look on the right, we see a picture of a histogram. So this is height of black cherries. Down at the bottom on the x-axis we see the height in feet, and on the y-axis we see frequencies. So this tells us how many black cherry trees fall within those height ranges. The reason we use histograms is because it groups all the data that could be the same in the same category. So data could be the same even though the values are different because of inaccuracies in the tools that we use in measuring. So if you think back to the experiment where you put the penny on the balance multiple times, you realize that the mass of the penny doesn't change, but sometimes you have different readings. So because we have different readings, we have an error level in our balance. We might have found the error level in our balances to be plus or minus 0.01 grams or plus or minus 0.02 grams. We need to make sure that everything, all the data that could be the same, is in the same category, and that's what histograms allow us to do. So as you saw in our experiment, our balances aren't perfect. If we put the same object on the balance multiple times, we could get different readings even though that object still has the same mass. So in histograms, all the data that could be the same mass, or could be the same change in mass, all goes in the same bar. We're going to make a histogram to answer the question, do pennies all have the same mass? So to do this, I already have the data collected. So I have 14 different pennies measured and their masses. So on the left I have the year of the penny, and on the right column I have the mass of the penny. Looking at that first mass, we see the mass is 2.51 grams. Now remember from our sensitivity of the balance experiment that the actual mass of that penny could be somewhere between 2.50 to 2.52. So when we make a histogram, we're taking that range into account. When you create a histogram, what you're really doing is putting data inside bins. So here you can see the bins that we have made. Each bin we're going to put the data that could possibly be the same because of the error in the balance. So the example that I talked about earlier was that mass of 2.51 of the penny. Now the actual mass of that penny could be 2.50 or 2.52. So we create bins where all those data points go in the same bin. The way we have it set up here is that we have the edges of the bin marked by the pink note cards. Now those edges of the bin would be the lines on the graph paper that you'll actually make. The middle of the bins are labeled by the blue note card. We're going to show you how we decide which bin each data point goes into. Now that we've collected all of our data and we have our bins made, our pale Esteban here is going to show us how to place each data point into a bin, into the proper bin that it belongs in. So what he's done is he's taken a set of blocks and he's labeled them with each data point. So each block will really represent a square on your graph paper. It's the same as filling in a square. We'll show you how to make the actual graph later, but we're going to show you how this really works using these bins. So the first data point he has is 2.51 grams. He's going to go to the bin and he sees that 2.51 grams falls on the line between two bins. Every time a data point falls on the line, it's going to go into the bin to the right. The second data point is 2.54 grams. 2.54 is the middle of this bin, so it's going to go in that bin to the right. The next data point is 2.51 grams. Again, that falls in the line, so it's going to go into the bin to the right. The next data point is 2.50 grams. That's going to go into the bin where the middle of the bin is 2.50. The next data point is 2.49 grams. That data point falls on the line between two bins, so it's going to go into the bin to the right. Now we're going to pause it here for a second because we can see that this highlights why histograms are important and useful to us. So 2.49 grams and 2.50 grams are in the same bin. Now we learned in the sensitivity of the balance lab that those two data points could possibly be the same. That 2.49 and 2.50, because of the error in the balance, could be the same measurement. So that's why we're using the histogram. We're going to put those in the same bin. 2.47 grams falls on the line, so it's going to go into the bin to the right. And you can see a bar graph or a histogram starting to be formed here. 2.52 grams, 2.52 is the middle of the bin, so that goes in the same bin as the two data points that are 2.51. Those could be the same mass. 2.48 grams, 2.48 is the middle of that bin, goes in the same category as the 2.47 grams. Those could be the same masses. 2.47 falls on the line, goes into the bin to the right. 2.50. 2.50 is the middle of that bin. That column's getting larger. 2.50 again. Same bin. You can see the shape of the histogram starting to form as we add more data. 2.48 grams. It's the middle of that bin. So each one of these stacks of blocks will end up being a column on your histogram, on your actual graph paper. 2.50 grams. Middle of the bin. Add it to the column. 2.50 grams again. Middle of the bin. Add it to the column. And the last data point, 2.51 grams. Falls on the line. Add it to the bin to the right. And that's all we have for the histogram. Esteban likes it. So reviewing, every bin now has data that could be the same in the same bins. So looking at this data, not all the data is exactly the same, but as you saw from the sensitivity of the balance experiment, the data could be the same. So when you took a stopper and put it on the balance multiple times, you got different readings that were off by probably 1/100th of a gram. So we take that into account and put everything that's off by 1/100th of a gram and put it in the same column, saying that these could be the same measurements or the same mass. So now we're going to take our data and we're actually going to make a histogram on a piece of graph paper. So instead of using the bins, we're going to translate that into an actual graph paper histogram. So the steps to make a histogram: number one, you need to label your X and Y axis. Number two, you need to find the mode in your data. Number three, you're going to use that mode to be this middle of your center bin. Number four is you're going to figure out the sensitivity from the balance from the data that you collected. For example, in the data that we collected from the pennies that we're using to make this histogram, each time we put a penny on the balance, we know that the mass could be plus 0.01 gram or minus 0.01 gram from the number that's actually read out on the balance. So our sensitivity for the balance, our error level for the balance, is plus or minus 0.01 grams. Then we're going to use that sensitivity of the balance to actually label our bins. So I'm going to take a look at the range of the data from the error that we have. So plus 0.01 grams and negative 0.01 grams, there's a difference of 0.02 grams between there. So each one of my bins is going to be 0.02 grams big, or have a range of 0.02 grams. Once I've labeled my bins, I'm going to plot the data that I have. And the last thing is I'm going to give my graph a title. Let's take a look at what this actually looks like. The first thing you're going to do on your histogram is you're going to label your X and Y axis. Then you're going to take a look at your data and you're going to find the mode in your data, or the data point that occurs most frequently. For our penny experiment, the most frequent mass was 2.50 grams. Your mode, in our case 2.50 grams, becomes the middle of your center bin. So you're going to label the middle of your center bin with the mode of the data that you collected. Then you're going to figure out the sensitivity of your balance for the experiment that you did. So in this experiment I measured one mass, the mass of the penny, and so I have an error level of 0.01 grams for every time that I measure the mass. So my error level is plus 0.01 grams and negative 0.01 grams. So that means that my range in data could be 0.02 grams from any measurement that I actually took. So I'm going to make my bin sizes, the sizes of my bin, 0.02 grams big. If I label my first middle point 2.50 grams, I'm going to label the middle of the next bin 2.52 grams. And I'm going to make sure that every bin is 0.02 grams big. Now that you have your axes labeled, the last thing you need to do is plot your data. So fill in a box for each data point that you found. Once you've done that, you give your graph a title, and you're done.